Hi, and welcome to this new video about kernel memory, where I'm going to explain how you can customize the ingestion pipeline. And we will immediately start from the end of previous example, because as you can see in the actual screenshot, I've give to kernel memory a PDF of an entire book to analyze and to index. And the text extraction extracted some weird characters. So this is the part of the index, the first part of the document, where you have all the index of the book. And the problem is you have a lot of weird characters in it. And this is usually a problem when you do RAG or in general for natural language processing, because this kind of data go into the index and create an index that is quite dirty. At the very beginning of the OpenAI ADA embedding, if you follow from long time, you remember that OpenAI suggested, before going and send the text to the model to create the embedding, they suggest to remove the new line because it will improve the quality of the vector. So the idea is, the more dirty is the text, the less effective the vector usually is, the embedding algorithm. So it is quite normal in a production environment to have some sort of cleaning up of the text that is usually extracted by standard extractor. All the library that you can use to extract text from a document, it can be Apache Tika or other library, it's not important. You always need to look at the text extracted and understand if the text extracted has a good quality to be used for indexing data. Luckily, kernel memory has a good way of customizing the ingestion pipeline. And it's very, very simple, because as you can see from the code, you can configure your kernel memory as usual. Then you can call your builder build the memory serverless, and then you can grab a reference to the orchestrator, calling the getOrchestrator function of the builder. It is important that you before call the builder build, because it builds everything. And after you build the builder, the kernel memory, you can get a reference to the orchestrator. That is the component responsible for orchestrating the ingestion of data inside your kernel memory. So it is the component that it extracts text and separate text into chunk, into segment, and then proceed to get the segment, pass to an embedding model to get the embedding, and finally index inside your kernel memory, inside the memory object, the vector database. And you can customize everything of this pipeline. So kernel memory is really, really flexible in such a scenario. As you can see, I'm simply proceeding to creating a lot of components that are handler, okay? And how can I create a good pipeline? So there are examples in the source code of kernel memory, and you can grab this example to see how the standard pipeline was built. And in this scenario, I'm simply adding one step, and it's the step declared in line 30 and 31. And it's my personal text cleaner that I put after the extract. So in this situation, I'm simply add a series of handlers to the orchestrator. And an handler is a piece of code that is capable of managing everything that can be done during the ingestion phase of your kernel memory server. So this is important. You need to register all the handler. Every handler you see is a basic handler that is composed and it is created inside, defined inside the kernel memory. And I simply added one, but you can add how many steps you want. And now there is the interesting part, because when you work with documents in natural language processing in your production environment, you know that you have various forms of document. And each company, each scenario has different documents, source documents. And you can find customers that have documents full of numbers, other full of images, and so on. So it is important, and kernel memory is really flexible in this scenario. It is important that you can choose the pipeline you want to use when you index a specific document. And kernel memory allows you just this, because if you see this piece of code, you can verify that you are indeed telling kernel memory to index a specific document, okay? with the add upload file. But before this, you can prepare new document of upload and you can select the index where you want to store the document. You can give a document ID and you can give a tag collection. So you can give a series of tag to this piece of document that you can use to filter documents. And after you specify the basic information, you just need to add the various handler you defined before. So what I've simply done is then extract. So you need to extract text from the binary file, then clean. And that is my custom piece of the pipeline that I'm configured in this scenario. And then you have all the other basic and default steps of kernel memory, like partition that is capable of partition the text, the summarize, the generating embedding, and the save records inside the memory. So as you can see, the key part of this example is that you can choose for each single document, which is the pipeline, which is the series of handler you will use to index the document. And this gives you great flexibility. And this is really important because when you create a RAG, a retrieval augmented generation solution, most of the people focalize on the search part, vector search, embedding, and so on. And this is the cool argument of this period. So everyone is excited about vector documents, but we have years and years of knowledge on the previous part, extracting and cleaning, because the extract phase in every natural language processing pipeline, where you can use RAG or you can simply use keyword search, because for years we live happily with keyword search only. The extract part is really important because it's the part where you try to extract relevant information from the document. You clean up what a standard tool can give you, because extracting from PDF, you can find a lot of libraries that extract from PDF, but in your particular scenario, maybe the PDF file is produced by some tools and you need some cleanup. So the extract phase is crucial, because if you have garbage inside your vector database, you will have garbage out. So you need to be really, you need to pay attention to what you are indexing. So it is a paramount importance that you customize and you check if indexed documents are good. And so kernel memory gives the ability to customize the pipeline, and that gives you a really powerful tool to obtain the result you need. Now I've rerun my example running my custom pipeline. So I've stored the book in another index. So you see I'm using the standard and not production ready, but useful for text disk storage. So I can simply look at what kernel memory write on my directory to understand what is happening. So it's really easy, and it's really good for testing what it's produced by the pipeline. And as you can see, I have two indexes. This is the default index, and if I'm going to look at what text is extracted at line 60, you see I have a lot of word characters. And this will consume token because they are indexed, so it's not a really good situation. And then you can see another index where I've run my custom pipeline. And now if I look at the text extracted, as you can see around line 60, I've removed everything. And now I'll give you the idea of how easy it is to create such kind of piece of text, how you can customize the injection pipeline. Your handler is a simple class that is implementing a special interface called iPipeline step handler. And it's the interface that identifies the ability of being part of an indexing pipeline. And you need to give a name to this handler because it's useful. It's needed for kernel memory to understand which is the name of your handler, so it can write on disk when this handler is executed. And that's the invoke async method that is simply past the pipeline. And so you have an object called data pipeline that contains everything, all data that was produced by previous handler. Okay, so now my handler start telling if I have no file. So if no piece of file is present in this pipeline, I have nothing to clean. And so I can go on. And then I can iterate in all the uploaded files into the pipeline files. So I can iterate in all the files that were produced by previous handler. Since this handler was put immediately after the extract handler, I'm expecting to have only one file and this is the text file extracted by the previous handler. But for simplicity, I can go and take the uploaded file and look at the generated file. So now if I have generated file, I can go and tells, okay, I check if the file was already processed by this handler, because this is important. This is idempotent. So if you already processed the file with an handler and the pipeline stop and restart, it writes that indeed this handler already processed this file, so it can be skipped. So you need to check for each file you're going to handle if you already processed this file with the very instance of the pipeline. And then if it's happening, you just log a trace and go on and continue to the next file, because you are not supposed to do anything to this file because you already processed it. And then I check the artifact type, because I just want cleanup text, extracted text, not images or other stuff that can be present in the pipeline. So I check if the artifact type of the file is extracted text. This means that it's text extracted from some tool, and I want to clean only the extracted text. So if this file is not an extracted text, I can just move on and say, I'm not interested in this file. And then I simply go with a very, very rudimental and not production-ready code, but this is an example. I'm simply iterating all the character extracted by the pipeline, and I'm simply removing everything that is not in the ASCII table. So I take punctuation, I take carriage return, and I take everything that is greater than 32 and less than 255. So I'm completely removing all the Unicode chars. And you need to understand if this is acceptable for your situation. For this example, it's okay because I know that I'm handling document written in English, so probably I'm not interested in any Unicode char. But pay attention, this is a really, really raw and really, really too harsh way of clean up your document. But this is an example. In this piece, you will put logic and take extracted text and do every manipulation is needed by your business to have cleaned text. And after you do your cleaning, you can just call the orchestrator write text file sync. And if you write in the pipeline with the same name of the file, you can simply override the previous content. So you can create new content with an handler, or you can simply, like this one, you can simply take something that is generated by a previous handler, in this situation, the extract handler, and you will simply process, maybe clean up, and you rewrite the content. So you remove the old content and you write a new one. And this is almost everything you need to do. And you need to remember to mark this file processed by this handler. So kernel memory infrastructure, the pipeline orchestrator, will mark this particular file as processed by an handler with this name. And this will allow for idempotence, because if you re-execute the handler again with the same file, you can, with the previous instruction, you can check that the file was already processed by this handler. So there is no need to process anymore. And nothing to do. And if you have new files, in this situation, I don't have new files, but if you have new files because your your handler generate more file, you can simply add the new files into the generated file of the uploaded file information. So it is really, really, really simple to create an handler that cleaning up previous extracted text or generate new text from your binary file, as an example. And this is important because this allows for very, very simple extension of kernel memory, where you can really, really index the data in the way you want it to be indexed. And this is the importance of using already made library for implementing RAG in your architecture, because it can give you the entire infrastructure tested, battle tested, and that can generate all the standard step needed for a RAG solution. But letting you insert it in this kind, you see in orange, your piece of customized handler, it allows you to just customize the little piece you need to customize to adapt to your business, to how your data is created and how your data is ingested into the pipeline. But this gives you only the burden of customizing a little step, leaving the library all the burden of doing the standard thing like extracting text, indexing, generating embedding. And this gives you the maximum flexibility and the minimum time needed to adapt a solution to your need. So kernel memory, if you work with .NET, it's a good choice because even if it's not so feature complete or feature full like other solution in Python, it's written in C#. It gives you a greater flexibility. And if you know C#, it's very, very easy to write just the little piece of code you need to customize your need. And this concludes this presentation. I strongly suggest if you work with .NET to take a look at kernel memory and just give it a try because it can give you a great satisfaction. Bye-bye.